Hello everyone. In this tutorial, we will analyze and visualize our dataset using Seaborn library. So as you can see, Seaborn is a Python data visualization library based on Matplotlib. So it provides high-level interface for drawing attractive and informative statistical graphics. So it's very helpful if you want to visualize your data more informatively and more statistically. So it's very useful library. So what we're gonna do, so this is our data set. So it is the automobile data set. So as you can see, so it has a large number of data, and different columns are make, fuel time, aspiration, number of doors, body style, drive wheels, engine location, wheelbase, length, width, height, curve weight, number of cylinders, and so many different columns are there. You can see in the data: engine size, fuel system, bore, stroke, compression ratio, horsepower, peak rpm, ctm, pg, highway, mpg, and price. So we will analyze this data set, we will visualize this data set using Seaborn library. So first of all, just go to the Google Colab, and first of all we will go to the files and we will upload this dataset into the session storage. So just click here and I upload this dataset into the session storage. And then here, from three dots, just select the this option, copy path. And so just select this copy path, and now I will close this. So what I'm going to do, I will import pandas as pd, I will import this library Seaborn as sns, I will import matplotlib.pyplot as plt, and I will set the sns.set color code equals to true. It means Seaborn now will support assigning colors to the plots using matplotlib color codes. So first of all, let's run this cell. So now I will import my data. So my data is in the csv format, so I will use read underscore csv file. So I will paste the path here and just run this cell. So now I will print this data. So let me print this data auto. So here you can see there are 205 rows and 23 columns, and if you want to print only particular rows, so auto dot head, and it will print the first 5 rows of your data set. So my data has been uploaded. So data has been uploaded, and this is the data frame. Auto is the data frame. Now I will use this data frame auto to visualize my data using sns. So now I will show how distribution of data, how you can view the distribution of the data for a single variable. So distribution of data, it will work only for numeric variables. So there are some numeric variables like this. These are the numeric variable, and there are some categorical variables. So distribution of data will work for only numeric variable. For that I will use sns dot this distribution plot, and here I will pass the variable. So I will pass this variable engine size. So I will pass this, and then I will use plot.show. So just run this code, and you can see, so you can see the distribution plot for the engine size. So where you can get an idea of how the data is distributed for the engine size. So similarly, I can show the distribution plot for wheelbase. So this is the distribution plot for wheelbase, and on in the x-axis there is a particular variable, that is wheelbase, and on the y-axis there is a density. and then I will show the distribution plot for the horsepower. So this is the, you can see x-axis there is horsepower, and on the y-axis there is a density function. So I am showing how the data is distributed uh, for the horsepower. And as you can see in this graph, uh, on the right side there is a kernel density, and if you don't want to see this kernel density, as you can see in the previous graph, in the x-axis there is a variable horsepower, and on the y-axis there is a density. So I don't want to show this density. For that I will, what I will do, I will just use KDE equals to false. KDE means kernel density equals to false. So let me run this, and now you can see there is no density on the y-axis. So it is showing me the distribution of the data, but it is not showing me the kernel density on the y-axis. So far we have analyzed only one variable. So we have discussed the distribution plot, so right now for only one variable, and now we will analyze more than one variable. So we will draw bivariate plots. For that we will use joint plot. So as you can see, so I will create a joint plot, and data is my data frame, and on the x-axis I will draw the horsepower, and in the y-axis I will use the engine size. So let's run this code. So as you can see, on the x-axis it is the horsepower, and on the y-axis it is the engine size, and it is a joint plot, and you can see the horsepower on the x-axis and the engine size on the y-axis. So this way you can create a joint plot between two variables. So simply use data frame, and then what variable you want on the x-axis and what variable you want on the y-axis. So another one is I will create joint plot between horsepower and engine size, but hue will be fuel type. So first of all let me run this code, then I will explain what do you mean by this hue. So just run this code, and you can see the horsepower on the x-axis and engine size on the y-axis as it was in the previous graph. Horsepower on the x-axis and engine size on the y-axis, but here I am using additional feature hue fuel type. So it will create two colors. Fuel type, actually we have two values in the fuel type, one is gas and one is diesel. So it will divide the data into the gas and diesel, and it will show you the you can see the points on the graph. So you can see, you can clearly visualize what points are of gas and what points are of diesel. So this way you can use another feature hue, and it will create different colors for each of the type, each of the fuel type. So let's create another graph, and same I will use horsepower on the x-axis and the engine size on the y-axis, and now I will use hue equals to body style. So let's run this code. So in the body style we have five values: convertible, hatchback, sedan, wagon, hardtop, and it is showing horsepower on the x-axis and engine size on the y-axis. And you can see the five different colors for the body style. So blue color for convertible, orange for hatchback, and different colors for different body style. And you can also see the scattered points on the graph. So it's very easy. You can simply use a data, and then x-axis, then y-axis, and then you can use the hue, and you can give any variable name here. So it's very easy to create the joint plot. Next we will create a joint plot between horsepower, engine size, and this type we will use a kind equals to histogram. So when you run this cell, so you can see that type of the chart is the histogram, and you can see on the screen. So first of all, it was a scattered graph by default, and now you can see the points like histograms. So this way you can change the kind of the graph. So all the remaining things are the same: data frame, then I am using x-axis, then I am using y-axis, and then kind I am using histogram. So another kind is you can see the regression type of the graph. So when you run this cell, everything is same, data is same, x-axis is same, y-axis is same, and now I have changed the kind of the graph to the regression graph. And you can see the x-axis horsepower, y-axis engine size, and you can see the scattered points, but this time you can also see the regression line. So it's very easy if you want to analyze your graph regression wise. So this is the regression line. So you can see the predicted point and the actual point. So it's very easy. So this way you can also create the regression line. And next is I am using data frame auto, x-axis horsepower, y-axis engine size, and this time I am using kind histogram, and I am using hue engine location. So when you run this cell, and you can see that we have two values for the engine location, front and rear, and it is showing you the same graph, horsepower, engine size, and this time hue is engine location. And this way you can analyze. So we have only few values for the engine location at the rear, and you can analyze. The horsepower is 200 and engine size is 200. So this value lies in this category. So this way you can also use the hue. So you can mix these variables. You can use x-axis any variable, you can use any variable on the y-axis, you can use hue on the any variable, and you can use the kind of any kind of the graph. So for analyzing, for visualizing your graph in a better way. And next I am using horsepower, engine size, and now the kind of the graph is a hex. So when you run this cell, and you can see the kind of the graph is hex. I have not used hue in this. I have not set the hue to any variable. So in the next I am using kind KDE, kernel density, and hue is fuel type, and same variables I am using. So you can see the KDE type of graph, and fuel type, as I have already explained, has two values, gas and diesel. And so this graph again is very helpful. So it depends upon you which kind of graph you want to use, which variable you want to use on the x-axis, which variable you want to use on the y-axis. So this way you can create a joint plot. So the next type of plot that we will use is the pair plot. So we have used joint plot, and it's useful when you want to analyze only two variables. One is on the x-axis and one is on the y-axis. So joint plot is very helpful. So next type of plot is pair plot, and it's very easy to use. So it is used for analyzing the multiple variables. So here I am using pair plot, and I am passing three variables: horsepower, engine size, and city mpg. So when I run this cell, you can see 9 graphs has been created. So horsepower, engine size, and city mpg. You can see horsepower, engine size, and city mpg. And so consider this graph. So this is the graph between the engine size and the city mpg. Consider this graph. So this is the graph between the city mpg and the horsepower. I have used only one command, and it will analyze all the variables. So it's very useful, you can see. So I am passing just three variables: horsepower, engine size, and city mpg, and it is creating a different graphs. So consider this. This is the graph between engine size and the horsepower. So this is the graph between the city mpg and the engine size. So this is the scatter graph, and the between the horsepower and this there is a bar type of chart. So our other charts are the scattered charts. So it's very easy to create a pair plot. So I have passed only three variables. Next I will change the variables. So I am be passing horsepower, engine size, and this time I am passing peak RPM. So peak RPM, now let me show you the data first. So this is my data set, and you can see this column peak RPM. So this is my peak RPM, and when I run this cell I will again see 9 graphs. So you can see horsepower, engine size, and peak RPM, horsepower, engine size, and peak RPM, and there are the graphs between each pair of the variables that I have provided. So pair plot is used to create a plot for each pair of the variables that I have provided. Next I am passing four variables: horsepower, engine size, peak RPM, and city mpg. And again I am using pair plot. It means this time it will create 1 2 3 4 16 graphs. So when I run this cell, so just wait while it is being executed. So you can see the 16 graphs on your screen. So only one command is used to analyze all the variables in a pair. So I'm providing horsepower, engine size, peak RPM, and city mpg. Horsepower, engine size, peak RPM, and city mpg. And see, all the variables are on the x-axis and all the variables are on the y-axis, and there is a graph between each pair of the variables. So it's very helpful to use pair plot if you want to analyze your graph, if you want to analyze your data set between any pairs. In the last part I discussed how you can create graphs of the continuous variables, how you can create different type of graphs of numeric variables. So we discussed different type of graphs in the last part. A pair plot we discussed, a joint plot we discussed, and distribution plot we discussed. So different type of graphs we discussed in the last part. So in this part let's try to create plot of one categorical variable and other continuous variables. So we will create plots of one categorical variables and other continuous variables. So first plot that I am going to use is strip plot. So I am providing the data and I am providing the x-axis. So let's run this code. So you can see the strip plot. So on the x-axis there is a horsepower and it is showing you the strip plot. So there is no y-axis on this plot, so let's add a y-axis. So now what I am going to do, in the x-axis there is a continuous variable, and on the y-axis I am going to add a categorical variable. I am going to add a engine location. So let's run this code. So you can see engine location has two values, one is front and another is rear, and on the x-axis it is the horsepower and it is showing you the strip plot. So this way you can create a strip plot of the categorical variable. You can use it on the x-axis as well, or and horsepower on the y-axis as well. Just change the coordinates x and y here. So similarly now I will create a strip plot for the horsepower and the make. So let's run this code. So first of all let me show you the make column in my data set. So just wait. So here is the make column and it is showing you the brand of the auto. So let's go to the cell. Okay, so here I am going to create a strip plot between the horsepower and the this is the categorical variable make. So let's run this code. So when I execute this code, you can see on the x-axis it is a horsepower, and on the y-axis the auto make, and all the strip points you can see on your graph. So very easy. Similarly, we can create a strip plot between the peak RPM and the body style, and here body style is the categorical variable. So let's run this code, and you can see the body style has 5 values: convertible, hatchback, sedan, wagon, hardtop, and peak RPM you can see, and it can show you the all the values on the strip plot. And as we have used the hue in the joint plot, we can use hue in the strip plot as well. So in the strip plot I am using the hue, and I am giving the body style variable. So x-axis is the body style, and y-axis is the peak RPM, and the x-axis I am giving the categorical feature body style. So previously I have provided this body style on the y-axis, but now I am using it on the x-axis, and on the y-axis I am using a numeric feature peak RPM, and here I am providing the body style. So let's run this code. So if you compare this chart with the above chart, you can see the different colors. So you can see the different color strips based upon the body style, because I am using body style as a hue. So this way you can use hue, and you can see the different colors, and on the x-axis is the body style, and on the y-axis is the peak RPM, and you can see the hue body style has different colors. Next plot is a swarm plot, and you can see we have created strip plots till now, and in the strip plots there is a overlapping of the points. You can see the points are overlapping with each other in each of the plot, you can see. So if you read the documentation of this swarm plot, you can see, so it is used to for better representation of distribution of values, and you can see there is no overlapping of the points, so the points don't overlap with each other. So in strip plots there is overlapping of points, and in swarm plots there is no overlapping of points. So I am using the data set. X-axis is the horsepower, y-axis is the fuel type, and hue is also fuel type. And if I show this plot, there will be no overlapping of the points. You can see there is no overlapping of the points, so it's very easy to use. And so swarm plot you should use. So in case your data is very small, if you want to observe only a small number of observations, if you want to draw only a small number of observations, so it does not scale well to the large number of observations, because there is no overlapping of the points in case of swarm plots. So I am using x-axis, y-axis, and hue, and if, you can use any values to understand this swarm plot. And you must compare the swarm plot with the strip plot. So you can use the same data for the strip plot and swarm plot, and you can compare both the plots, and you will be able to see in strip plot there is overlapping of points, and in swarm plot there is no overlapping of the points. So next type of plot is the box plot. So data set data frame I am providing. X-axis horsepower, y-axis is the make. So let's show this box plot. So you can see on the x-axis there is a horsepower, and on the y-axis there is a make of the auto make, and you can see the box plot for each of the make. So you can see the horsepower and you can see the make, and it is providing you the box plot, and a line here means the mean value, and these dots are the outliers in the box plot. So next I will create a box plot of the horsepower and the body style. So I have 5 body styles: convertible, hatchback, sedan, wagon, hardtop, and the horsepower. So I am creating a box plot for each of the body style, and I am showing the horsepower. And next I am creating a box plot for the body style. X-axis body style, y-axis is the peak RPM, and hue is the fuel type. So let's run this cell, and you can see the x-axis body style, and on the y-axis is the peak RPM, and hue is the fuel type. You can see, so you can see the fuel type hue, and it has two values, gas and diesel. And you can see the box plots. So advantage of providing hue is that it is showing you the two box plots for each of the body style. And this convertible has no auto, which has fuel type diesel, and this again has no auto, and this one you can see it has both the autos of the fuel type gas and the diesel. So this way you can better visualize your data. Next type of plot is the bar plot. So I'm providing the data, x-axis, y-axis. X-axis is the body style, y-axis is the city mpg, and let's run this cell. And you can see the body style on the x-axis and city mpg on the y-axis. And you can see these lines, actually these lines on the top are the confidence intervals of these bars. So this way you can create a bar plot. Simply provide, everything is same, just change the name of the plot, provide the data, provide the x-axis, provide the y-axis. And similarly you can use the hue also. So I'm providing body style, horsepower, and the engine location as the hue. And we have two values of engine location, front and rear. And you can see x-axis is the body style, y-axis is the horsepower, and for each of the body style it is providing me two bars, one for the engine location at the front and one for the engine location at the rear. And this hatchback does not have any value at the rear, and similarly this does not have any value at the rear. And this hardtop has a engine location at the front and engine location at the rear. And similarly I will create the x-axis body style, y-axis horsepower, and now I will use hue fuel type. So let's run this cell, and you can see the fuel type. I have two values, one is gas and another one is diesel. So body style, these five are the body styles. And for each of the fuel type it is providing me two bars. So you can see all these two bars for fuel type gas and diesel, and on the x-axis is the body style and on the y-axis is the horse power. Next is the count plot, and count plot shows the frequency. So how count plot is helpful? So I am providing the data frame, and on the x-axis I am providing the make column. And just show this plot. So it will show the frequency for each of the make, and you can see different makes are here, and it is showing the frequency for each of the make. But the problem is that on the x-axis all the makes are as you can see are overlapping with each other. So how to resolve it? So I will simply use a plot.xticks and rotation equals to 90. So I will rotate the x labels by 90 degrees. So just let's run this code again, and boom, you can see the makes are rotated on the x-axis, and for each of the make it is providing me the count, the number of values for each of the make. For example, Chevrolet, and it is providing me the, for Audi it is providing me the number of counts. So and you can easily analyze the data. So count plot is very helpful if you want to show the frequency for your data variables. Next I will show the count plot for the body style. So just simply run this code. Here I have changed the x-axis and I have 5 body style values, so it is providing me the count for each of the body style, as you can see. And again I am showing the count plot for the auto uh, make variable, and hue I am using body style. And you can see for each of the make, it is providing me the count values for each of the body style. X-axis is the make, y-axis is the count, and hue is the body style. And for each of the make, it is providing me the different values for body style, as you can see. So see how helpful it is. For each of the make, it is providing me the count values for each of the body style, so it's very helpful. Next is the point plot. So point plot is again very helpful. So I am providing x-axis body style and y-axis engine size. So let me first run this cell, then I will explain. So it will show you the how the points are connected with each other, how the values are increasing or how the values are decreasing. So it's again very helpful point plot. And next I am creating point plot between the make and engine size, and I am rotating the x labels by 90 degree, and I am showing the plot. And you can see the different makes. I have rotated xy rotated 90 degree on the x-axis, and it is providing me the plot points. So it's very helpful if you want to analyze your data, that how the values are increasing or decreasing in your data set. So for each of the, for example, for each of the make, and it is providing me the analysis of the different points. So it's again very helpful point plot. So in the last we will create a category plot. So I am providing x-axis engine location, y-axis engine size, hue is the number of doors, column is fuel type, and data is the auto data frame, and type of the plot is swarm plot. So let's run this code, so I will explain it. So yeah, you can see the x-axis, there is a engine location. So engine location is on the x-axis, and engine size is on the y-axis. So engine axis is on the y-axis, and hue is the number of doors. So here a number of doors 2, 4, and for some data points it is unknown, so it is showing unknown and showing green color. And for the number of doors, it is creating the two graphs. It is creating two graphs because I have provided column fuel type. So I have two type of fuel, gas and diesel. So it is creating two graphs. So this fuel type is the column. So one column, second column, one column is gas, so it is creating graph for the gas, and another column is diesel. It is creating a graph for the diesel, and on the x-axis engine location, and on the y-axis engine size. So it's another way of visualizing the data. So another category plot that I am going to use is the you can see the its kind is count type of plot. So x-axis engine location, here is the number of doors, if column is the fuel type. And let's run this code. And here you can see that here is the number of doors, and same 2, 4, and its value is unknown. X-axis is the engine location, and it is showing the count because I am using the count type of graph, and it is calculating the frequency. And column fuel type, so columns are 2, gas and diesel, because it is creating a you can see the columns are fuel type, one is for gas and another is for diesel. So this way you can create the a category plot. So you can try all the other options, you can try all the numeric features and categorical features for visualizing the data using a Seaborn. So it's that's all for this tutorial. I hope you have learned a, a lot regarding different type of plots and how we can visualize our data. Thank you for watching.